Hi, welcome to this lecture on mathematical methods for biology. We have been talking about various functions and how to play around with these functions, that is finding slope, given slope how to find functions, and we learned that this has many applications and many quantities in biology are either derivatives or integrals of various functions like various examples that we saw so far. Now, we said that mathematics is like a language and we want to use that language to convey something that we see around us in nature and in particular things in biology. So, when we want to describe biological things in the biological world or the living world, very often you would have some quantities that has a particular direction, like there is life. In many things in life has a particular direction, and in the molecular level or in the at different length scales, things will have a particular direction, movement will have a particular direction, many things will have a particular direction. So, how do we represent those quantities that have direction is something that we will discuss today. So, the title of today's topic is Scalars and Vectors. That is a topic today that we will discuss, and the question we will answer is, how do we mathematically represent quantities that have a direction? This is the question that we will answer today. So, to start, let us think about things that we have been learning. Like we just said f of x so far very often, and so when we say f of x is equal to 3 or f of x is equal to x square, these are some, I can substitute values for x. When I say f of x is equal to sin x, I can substitute values over x and I will get a number. So, essentially all of these are numbers. So, some function was x, these are all numbers. So far whatever we learned are some quantities that has some numbers, typically that we would measure, like concentration, right? We would measure the concentration of things, and many things that we measure are simply numbers. So, these things are called scalars. So, the name for them is scalars. Scalars are just numbers typically representing magnitude of some quantity like mass, which is the magnitude of magnitude, and the concentration, which is also magnitude of number of molecules in a particular volume, temperature, which is also the magnitude of kinetic energy or hotness, and basically all of these are some quantities representing magnitude. Very often you would talk about numbers, which is also related to concentration. So, numbers, concentration, mass, temperature, these are the things that we typically would be interested or we discussed so far, which are called scalars. So, the name is scalars. So, mathematically they are called scalars because they are simply numbers. So, they are just numbers, and this would have no direction, no particular direction, just magnitude only. So, this would typically represent the magnitude of something. So, now what do I mean by all this? It will be clear. Now, let us think about some other quantities which are not scalars. So, many phenomena in nature have specific direction. So, there are things that have direction. When we talk about direction, what are the things that would come to our mind? The first thing that would come is something is flowing. So, flow has a particular direction. I am moving in a particular direction. So, the motion has a particular direction. So, for position itself, like I am standing left or right, I am standing ahead or back. So, when we talk about position relative to something, or when we talk about motion, which is you are moving in this particular direction, or when we talk about flow, flow is in a particular direction, all of these have quantities which have direction. So, let us write down these things. So, the things that quantities that have direction flow. So, when we have to say it is flowing in a particular direction, right, it is flowing this way or that way, right, this is a particular direction. Movement. So, moving forward, backward, position with respect to some point, right, you are positioned at the left side or right side, right, left side, right side. These are things that we would typically use in English, and when we think about flow, for example, we very often molecules will flow from one direction to the other direction. Something that would come to everybody's mind is related to diffusion, like diffusion is some related, there is a flow related to diffusion. So, this was something which would come in our mind typically. Is the diffusion, what is the things that is related to diffusion which has, there is a current flow associated with diffusion which we will discuss, or concentration flows, right, concentration flow. There is a flow of concentration, flow of molecules from one place to the other direction, particular direction, higher concentration to lower concentration is what is diffusion. So, these are the things that are quantities that have a direction. So, examples here, vectors are flow, a force is a particular direction, you apply a force, you push somebody in a particular direction. So, they all have a specific direction. Now, the question that we want to discuss is, how do we represent this mathematically as a language? When we want to say something that is mathematically, how do we represent this? So, this is the first thing that we, so the question we are going to answer is how. How do we describe direction mathematically? So, this is the question that we would answer. Now, let us think about something that we would want to typically convey in an experiment or in a particular context which has a direction. Simple thing to say is that push in a particular direction. Let us say I have this pen, I would want to lift this up. So, lift this up in this direction, right. So, how do I say that lift up or pull down, right. So, let us say lift this up or pull down. So, these are the things that we would want to tell somebody. So, apply a force in a particular direction. So, how do we tell somebody that lift a box? Lift would mean that push upward, right? Push or apply a force upward. This is what we want to tell somebody. So, we could say that go and push or pull. In the door we would have push, pull. So, this is something that we want to say in a particular, you are instructing somebody to do something in a particular direction. You don't want, if it is in the opposite direction, it will not work. So, we wanted to have force F, and this should be in a particular direction. So, to show that this has a direction, one would typically use this notation, this arrow, which is a symbol which is representing that the force is a quantity which has a particular direction. Now, we wanted to say upward, this is the direction, or downward, or to the left, or to the right. This is the simple direction in a plane, in this two-dimensional world of plane. We could just say essentially these are the things that we would say: upward or downward, left or down. So let us first think about how do we represent, how do we tell somebody to apply a force in the upward direction, push, pull, left, right and all that. So the way to do that is, again going back to the graph. So if we go back to the graph and when we draw this x and y axis, we all know that we have an xy plane. So this is x, and in the simple world this is y. In this 2D, this is x, in this y. So if I have a box here, if I have an object here, if I want to move this upward, I have to apply a force in this direction. So the direction of the force has to be this. So I want to tell somebody that apply a force, I have to apply a force. What is the unit of force? Which is in Newton. So let us, I want to apply a force of 3 Newton. I want to apply a force of 3 Newton or 3 piconewton or 3, whatever be the unit of force. A force of 3 Newton one would want to apply, but in this direction of upward. So to say that you should apply in the direction of y axis. So this is the y hat. So if I just put y and the symbol of hat, so this is called y hat, and this would mean that when I write this mathematically, this is an instruction given to somebody which says, with the meaning of this instruction is that apply 3 Newton force in the y direction. So this is something that we want to say in English: apply 3 Newton force in the y direction to push this up, and this can be said mathematically in simple words: F is equal to 3y, and just to show that F is a vector, you will put a vector sign here. F is equal to 3y. This would mean that apply a force upward in the direction of y. Now, if we want to say this, now let us think about what if we want to just say the opposite. Let us say we want to say that apply a force and then pull it down. So we have this, and this is the increasing direction of y, this is the increasing direction of y, and this is the increasing direction of x. Now we have an object here, and we applied a force in this direction, but one would want to also apply a force in this direction to pull it down, right? So we could, if we want to say that pull down the box applying 3 Newton force. This is the instruction we wanted to convey to somebody. Apply this box, pull down this box, bring it down, pull down by applying 3 Newton force. So the way to say this is that we have to say, you have to apply force has to be 3, has to be the magnitude, 3 Newton, or whatever be the unit. One has to appropriately put the unit here, 3 Newton, in the direction downward. So how do I say that? I would say minus y hat, So that is downwards. So this would imply this is equal to minus 3 y hat. So when I say f vector is equal to minus 3 y hat, this is essentially telling, this is an instruction given to someone that pull it down with this much force. So this is the magnitude and this is the direction. So this is the magnitude and this is the direction. So this is the magnitude of the force and this is the direction of the force. So there is a magnitude and a direction. So this is an example of a vector quantity that we would want to convey, that how much force one should apply is an example of a vector where we would convey to someone that do this way. Now let us think of some other way that if you want to same thing, you want to say that run in that direction, right? So we want to say that the molecular motor is moving towards the center of the cell. This is something that we would want to tell, right? So let us think about this context that we would want to say in a biology. So let us think of this context. We have a cell, and cell has a center which is here, and this is the exterior, right? So this is the cell and this is center now. So you have molecular motors walking along the microtubule. So there are many microtubule tracks, and molecular motor would either go this way. Let us say molecular, we want to say that molecular motors are going inward, right? We would want to say this. How would we say this? So this is something, for example, or some other molecular motor might be going outward. So if you want to say that another molecular motor, which is shown in this red, is going outward along this track. So this motor is walking to the exterior, which is this way, or the vesicle is going in this way, and the vesicle is moving this way. So we wanted to tell somebody, look, that particular vesicle of your interest or a particular molecule of that interest, is going inward. Look, that particular molecule of your interest is going towards the cell membrane, cell periphery. So this is something we would want to convey, like vesicle or molecule of your interest is going towards cell periphery. This is very often we would want to say. We would also want to say that it is going towards the center. Molecule is going towards the center of the cell. So now if you want to say, how do we mathematically say this? This is the training that we were getting through understanding vectors. We are training ourselves to say this thing mathematically. So now we will reach here, but before reaching here, we will think of even simpler thing, which is moving left and right. So moving towards center or periphery is easy to say, but we need to get a training to do that. Before that, let us think of a simpler case, which is moving to the left or to the right. So where we would think of an in vitro experiment. Let us think of an in vitro experiment where you have just a setup where you have microtubule track, and on which a molecular motor is carrying a vesicle is moving from one direction to the other direction. So let us say this is the plus end of the microtubule and this is the minus end of the microtubule, and a motor is moving in particular direction. So if you want to now to say that this is moving to the rightward or to the leftward, how do we say that? We would say that it is moving. So motion is often represented by this thing called velocity. Velocity is something that represents motion. What is velocity? Velocity is nothing but speed with a direction. Speed plus direction together is essentially velocity. So we want to say that a molecular motor is moving this way. We would want to use the following, that we want to say that velocity, which is a vector, it is moving with a velocity of 10 micrometer per second. So the velocity magnitude is 10 micrometer per second. This is the magnitude, and it is going along the x-axis. So we would put x cap. So if I write this means that the motor is moving along the x-axis towards positive x, So this would mean that the motor is going towards positive x with a speed of 10 micrometer per second. So this is what it would mean. The same thing if you want to say in the negative x direction. So the opposite context would be you have an in vitro experiment again, where you have a track in which a vesicle cargo would move this way. So this was the minus and plus ends of the microtubule. So you have a cargo which is moving towards this way with the same speed. So we would say that as the following: v is equal to 10 micrometer per second is the velocity or the speed, but it is going in the minus x direction. So minus x cap. So in other words, I would write 10 x cap with a minus sign, and the unit is micrometer per second. So 10 x cap would mean that 10, whatever be the unit, it is going in the minus x direction. So this is the first thing we would want to convey something. This is the simplest thing we would want. But very often we would want to use a little bit more complex things, which is, think about this. You have a plate which is like this, and we would define x axis and y axis like this. So this is my y and this is my x, and you have a microtubule which is lying like this, and you have a cargo which is moving this way. So this cargo, if we consider the edges of the plate as x axis and y axis, and you have a cargo moving in this direction, it is neither moving along the x nor moving along the y, but something which is a combination of x and y. So what one would say is that this is going, so if I start from here and it reached here. So if this is my initial position and it moved here, later it reached here. So it is moving along this direction. So it is moving along the x and y. So it is moving this way a little bit and this way. So the way to say is that if you want to reach from here to here, we have to first go along this and then go along this. If I go first this way and this way, I would reach from here to here. So if I just want to say that it is going in this direction, and this direction is a combination of x and y. So it is going a little bit along the x direction, a little bit along the y direction. Then it would be a movement which is diagonal like this, which is a mix of both x and y. So then we would say that this has some velocity v, which is some amount of motion along the x direction and some amount of motion along the y direction. It moves a little bit. If you go a little bit along x direction and go a little bit along the y direction, I would get this y. So this is the magnitude which I would put, let us say t, 2 and 5. These are some two numbers, and what does this mean? We will think about it a little bit. But if I just say v as 2x plus 5y, this represent movements like this, which is both a combination of x and y. So this is a v vector. Generally, any vector would be like this in a two-dimensional plane. It will have some x and y direction. So now, how to get this x and y direction is something that we want to understand. To understand that, let us think about position and let us think about other things. Now, talking about force, which we said as a vector, we talked about force, and very often one thing that is force is two charges. So two charges typically attract or repel. For example, you have a plus charge here and a minus charge here, and this minus charge will be attracted towards this plus charge. So if I keep this charge fixed here, this charge will move along this direction to come towards this plus charge. So if you want to say that the direction of movement of this charge again we would want to use idea of vectors. So this is the magnitude of the force and this is the direction of the force. Similarly, if you have two plus charges, one of the charges, if assume that if this charge is fixed at some location and the other charge is free to move, then this charge will move away from this charge, and the force of movement, the force of repulsion on this charge would be q square by some constant times r square, where r is the distance, and therefore the magnitude of the force is this and the direction of this would be this. And if you want to write this thing mathematically, what we would write typically is that, so you have this plus charge and a minus charge, and we know that if you fix this charge will move in this direction. So, and the force felt on this charge is some constant q square by r square. It is, this constant typically could be written as below also 1 over k, does not matter, it is some constant, but it has a direction, and in this direction the direction is minus x. It will move in the minus x direction, where q is the magnitude of the charge. Okay, q is the magnitude of the charge and this will move in this minus x direction without a sign. Okay, here. So this whole thing will have a sign. Now if you take two plus charges and if you fix this charge will move in this direction and the force will be repelling, and that force again can be written as q square by r square along the x direction. It will be along the x axis. So this will be written as x cap. So these are the ways to represent vectors in an xy plane. So to summarize, what we said so far is what is the simplest way of representing direction. So we just had an introduction to vectors. So we had introduction to vectors. That's what we did in this module, introduction to vectors. And we said that any vector force can be 3x cap, or force could be minus 3y cap, that means 3 along the negative y direction, or it could be some combination in principle. Velocity, we said in the case of velocity we saw that velocity could be some combination of 3x cap plus 4y cap. So these are the simple ways of representing a quantity that has magnitude and direction. We would discuss this in more detail in the coming lectures and understand this and answer this, try to answer the big question that how do we say that something is going inward or outward of the cell, and so on and so forth. So with this we will stop this lecture and continue in the next lecture.